The halogenation of an alkene is a type 2 electrophilic addition reaction where the alkene attacks an electrophile with its own lone pair of electrons. In terms of the curved arrows then, the alkene acts as a nucleophile, the alkene breaks, carbon 5 gets to keep those electrons and attack the electrophilic bromine. That builds up too much electron density around bromine, so the bromine-bromine bond breaks and the electrons get deposited onto Br- as a leaving group. We're attacking an electrophile with its own lone pairs of electrons, so that lone pair bites back down on the would-have-been carbocation, forming the bridged bromonium ion intermediate. Here I've shown the intermediate where the bromine attacks from the top face of the alkene, but it could just have easily attacked from the bottom face as well, forming an enantiomer of this intermediate. In the final step of the mechanism, Br- acts as a nucleophile and will attack one side of the bromonium ion intermediate. This will proceed as if it were following Markovnikov's rule, where the bromide will attack the would-have-been best carbocation, which would be carbon 6. Br- will use its lone pairs to attack carbon 6. That builds up too much electron density around carbon 6, so the carbon-bromine bond will break, putting those electrons onto bromine as the leaving group. That means when we draw the product of this mechanism, the Br- that we just added to carbon 6 will end up on a dash, flipping the methyl group up to a wedge. The bromine on carbon 5 will still be on a wedge because carbon 5 was not attacked in that last step. The only mechanistically legal way for Br- to open up the bromonium ion is to attack from the face opposite of the original bromonium ion. These two bromines must be anti. This is a stereospecific mechanism. Of course, as I mentioned earlier, this intermediate could also have been the bromonium ion on the dash if the bromine had attacked from the bottom face instead of the top face, so we end up with this product plus its enantiomer. This is the mechanism for the halogenation of an alkene.